Hello everyone, I am Dr. Abha Kumari. Today we will discuss the particular integral for non-homogeneous linear equation with constant coefficient. And earlier we have discussed the complementary function for this type of problems. So today is a particular integral. So in this particular integral, first we discuss the case 1. So in this case 1, we have the non-homogeneous partial differential equation are very similar to those used in solving the linear equation with constant coefficient for pi. So here we consider the few cases. Now case 1. Case 1, that is the particular integral. Fine. Case 1. When the right hand side side of differential equation is of the form like this: e to the power ax plus by. Okay, this is the form of the differential equation, the right hand side. Then for the pi, we will write 1 by f dd dash e to the power ax plus by, and this is equals to 1 divided by f of, we will put a in place of d and we'll put b in place of d dash, and then we multiply e to the power ax plus by. Fine. Provided f of ab not equals to 0. Fine. Now case 2. Sorry, this is the case 2. In case 2, when the right hand side of differential equation is of the form sin ax plus by or cos ax plus by, then the pi is equals to 1 by f dd dash sin ax. Okay, so here is ax plus by. Earlier we have seen the sin ax sin by like this. Sin ax plus by is also we have done. So here we will put d square equal to minus a square and d dash square equal to minus of b square. Fine. Provided f of ab not equals to 0. Okay. Now case 3. In case 3, when the right hand side of a differential equation is of the form x to the power m and y to the power n, that is our algebraic function in both x and y terms, where m and n are positive integers. Fine. When m and n are positive integers. So here in this case, we just do like this: 1 by f dd dash into xm, and then we have yn, that is f d dash. We will put this in terms of d dash in terms of inverse, and then we find the integration or differentiation, whatever the need of this function. Fine. Now next is case 4. Case 4. When the right hand side is of the form e to the power ax plus by into v, that means exponential and some function of v. Okay, v might be the algebraic function, v might be trigonometric function, whatever it is given. So here we will write in this function as 1 by f d dash into e to the power ax plus by. Fine. And then we have v. Here it is in multiple form. So what we do here is we will just put the ax plus by here and we apply f. D is replaced by d plus a and we will replace d dash as d dash plus b. Fine. And then into v. We have discussed this type of problem lot in homogeneous type. So I don't feel that you will all get the difficulty. Okay. So let us see a very short problem. Fine. So here is the question. Questions. Solve d square minus d dash square plus d minus d dash into z equals to 0. Earlier when we have discussed this type of problem, we have the homogeneous equation now. So here we have non-homogeneous linear differential equation. So what we do? Solution. First we write the given equation. The given equation is, what the equation given is, d square minus d dash square, then what we have, plus d minus d dash, and this is equals to what? Equals to into z equals to 0. So now factorize this one. So what we get here is d plus d dash and then d minus d dash and then plus 1 we have having a d minus d dash, okay, into this one into z equals to 0. So this implies we can write this one as d plus d dash. You're having here plus, so plus 1. Fine. D plus d dash plus 1 and then d minus d dash equals to, into z equals to 0. Therefore, its auxiliary equation is, we can write the auxiliary equation in terms of d. So d plus d dash plus 1 into d minus d dash equals to 0. So what we get here? First from this equation, a d plus b d dash. So therefore, what we write it for this function? For this, we have what? Here with the coefficient of x, whatever is here, and the coefficient of y. So here it is minus 1. So what we will write here is, have you remember what we have written earlier? Yes, fy plus mx. Fy plus mx. Fine. So here it is d minus d dash. No. So what we write here is f1 y plus x. Okay. And then plus. Now here you see, here it is plus 1. Okay. So plus 1. So what we are getting here is minus 1. After replacement, so we write f1 y plus x, and then for the second function, this one, so we will write it like this, e to the power, here it is plus 1. But when we have discussed the case, what we see is d minus m1 d dash and then minus alpha 1. So this is the standard form. But here we see that d plus d dash now, so we will write it like this, minus 1 into minus 1 again. So what we write it, minus of, d of d plus d dash plus 1 we are getting. So we will write like this, d minus of minus d dash, this one, that is minus 1, and then plus 1 we are having here. So we will write minus of minus 1. Fine. So this is the case. So what we write for the solution of this function, what we write is e to the power alpha 1x, and then we will write f1 y plus x. So for this function, here it is a plus and then plus, so we will write like this, e to the power, what we are getting, minus sign now, so minus x. Fine. And then we are having f2. Since we f1 we have used, so we will write f2 and then bracket y minus x. Here it is minus 1. Since we are having the minus and then we have m1 d dash, so that's why we are writing here y plus m1x. Sorry, it is m into x. It is m into x. So we will write y minus x. So here in this type of such problem, what we write here is z equals to f1 y plus x and then plus e to the power. For this one, we will write e to the power minus x and then f2, then y minus x. Is it clear to you? Okay. Let us see some another example. So next we have some another example. Let us this question. Solve r plus 2s plus t, okay, plus 2p plus 2q plus z equals to 0. Let us see this question. What this r is? R is del 2z by del x2. So del 2z by del x2 plus 2 del 2z by del x del y. Okay, fine. And then we have del 2z by del y2 plus 2 del z by del x, then plus 2 del z by del y, and then plus z equals to 0. So we can write this equation as this term is equals to, okay, fine. So this can be written as this is equals to what? D square plus 2d d dash plus d dash square plus 2d plus 2d dash plus 1, then z equals to 0. Fine. In this way. So here after factorization we get the sum d. So here we get, or this is d plus d dash plus 1 whole square equals to 0. Okay, so the solution of this equation is, since here we get a repeated root, how much time? The 2 times. So the solution is z equals to, we will write it as e to the power minus x, y minus x, again the same concept. Here it is plus 1, so we are making it minus 1. So there is minus of minus 1, so minus of x. Fine. Then we have f1 y minus x, again minus, because we are getting d plus d dash, so this is y minus x. Okay, and then plus x into e to the power, again minus x. We are multiplying here x y because it is repeated 2 times, and then we are having f2 y minus x. Okay, so this is the complementary function when we are having repeated root. Okay, thank you.